Hello. In this video, we're going to continue our study of counting and organizing. We're going to start off with some cats. Suppose there are 4 cats, Abby, Bella, Cabby, and Dora, and we want to find out how many ways we can line up 3 of them. Well, this seems like a blank method kind of question. We're going to put the cats on a line. There's 3 of them, draw 3 blanks. Now at the beginning, we have 4 options, Abby, Bella, Cabby, or Dora. So we would put a 4 in the first blank. Then we can't repeat cats because, we can't like clone them or something. So after the first blank, we only have 3 cats and then 2 cats. Each cat takes a spot. Well, I guess not all the cats. One of them gets left out, but that's okay. Multiply these numbers, 4, 3, 2, and 4 times 3 times 2 gives 24. So if you have 4 cats and you're lining up 3 of them, there are a total of 24 ways of doing this. And if you started writing them out, right, you would have ABC or ABD. You could have maybe ACB or maybe CBA, right? There's all sorts of ways we could do this. Now, the problem though is this. If you actually have any cats, they don't stay lined up nicely. Cats aren't like dogs. Cats are pretty hard, if not impossible, to train. And so if you try to take a group of cats and you take 3 of them and you try to line them up, they're just going to wander around. They're going to go look out the window, play with their tail, find a ball of yarn. They're not going to stay nice for the photo. And so really, we're not lining them up as much as we're making a group of 3 of them. What I mean by this is if you have Abby and Bella and Cabby, because you can't really get them in a line and they're more just in a group, this is the same as if you pick Cabby and Bella and Abby. These are both going to be considered the same because they're not going to be in a line. We're really only going to be picking a group of cats. So again, we have those 4 cats, Abby, Bella, Cabby, and Dora. And I would like you to figure out how many ways you can make a group of 3 of them. Go ahead and pause the video and give it a try. All right, so we would have as the following options, ABC, ABD, ACD, and BCD. And I think that's it. Because one way to think about it is you have to exclude 1 cat from the group. So here we're going to exclude Dora, the D cat. Here we're going to exclude Cabby. Here we're going to exclude Bella. Here we're going to exclude Abby. But other than that, I mean, these are the only options because if you rearrange the letters, we're still considering that the same group of cats. Okay, so the answer is 4. How in the world would you come up with this answer? And that's where we have a bit of a question here. We're wondering what kind of formula, what kind of shortcut would give us 4? Because before we had the blank method and that gave us 24. Seems pretty tricky to try to get 4. So I'd encourage you to pause the video. If you want a bit of a hint, you could try looking at your formula sheet and see if there's any formulas that might work for this situation. All right, so some of you have probably seen that C formula, NCR. That means n factorial over n minus r factorial. So in our example, if we have 4 cats, see 3 of them, that's 4 factorial over 4 minus 3 factorial, which equals 24 over 1 factorial times 3 factorial. So 24 over 6. Which, yeah, that equals 4. That gives us the right answer. And if you try it right on your calculator, you should have it just equal 4 as well. Okay, but this totally could just be a coincidence. We need to actually test this on another example. So let's try a group of 2 cats. Again, remember, we have 4 cats, A, B, C, and D. And I would like you to write out all the different ways you could choose 2 of them to be in a group. Remember that if you choose A and B, that's the same as B and A, because the order that they're lined up in doesn't matter. It simply matters the grouping of cats. All right, so assuming you gave that a try, let me write out all the groups I can think of. There's AB, AC and AD, BC and BD, and CD. And I think that's going to be it. That's a total of 6 groups. Now if we try 4C2, that gives us 4 factorial over 4 minus 2 factorial 2 factorial. We could write that as 4 times 3 times 2 factorial over 2 factorial 2 factorial. So that's going to be 12 over 2, which is 6. All right. It looks like the formula gave us the same answer. Now, I would like to explain this formula a little bit for you because it's not just a random formula. There is some idea here, some logic behind why it works. And this is how I would explain it. Our initial answer was always going to be 24, right? This was always 24 with the blank method, and that comes from the 4 factorial, which you can see is in the top of the formula. But we have to modify it a little bit. And so what we're doing is, well, first off, we're modifying it because we're only choosing 2 cats. So if you imagined choosing 2 cats, you would do 2 blanks, 4 times 3. And so really we should only have a 4 times 3 in the top, which will be 12. And we can see that 12 that's been modified right here in the formula. Maybe I'll do that in another color here. We can see the 12, or the 4 times 3 right here. So this 2 factorial business that cancels out is kind of setting up the fact that there's only 2 blanks. We're choosing 2 cats, so only 2 blanks. So we have to modify the full 24 down to just the 2 cats. But why is there this extra 2 factorial in the bottom? The way I would think about this is that because the 2 cats are running around and there's really no order to them, AB equals BA. In other words, you could almost think about the cats as like identical letters. Identical letters. Remember, when you have a repeated letter, you have to divide by 2 factorial because there's 2 repeated letters. Because the 2 cats are the same, AB and BA, the cats are kind of like identical letters, so you have to divide them out, and it gives you 6. All right, no matter how you think about it, this formula is what we need to do. Whenever we're choosing these cats for these groups, we have to use the C formula. So let's say there's 10 cats and we want to choose 3 of them to be in a group. How many ways are there to do this? Go ahead and pause the video and give this a try with the formula. All right, so you should have 10C3, which is 10 factorial over 10 minus 3 factorial, 3 factorial. 10 times 9 times 8 times 7 factorial over 7 factorial times 3 times 2 times 1. We cancel the 7 factorials. The 3 is going to cancel with the 9 to give 3. The 2 cancels with the 8 to give 4. So now we have 3 times 4 times 10. So that's going to be 120. So that's how you do it without a calculator. With a calculator, you can go ahead and just type it in. You should find that C button right underneath the division. So you would type in 10, shift, divide to get the C, and then 3, hit equals, and it will just give you 120 right away. So the 10C3, the way I like to think about the C is I think about the C standing for the word combination. Because what we're doing here is a combination, not a permutation. And in a combination, it means that the order doesn't matter. It means the order doesn't matter. So for our cats, because they're running around and they're in a group, not in a line, it doesn't matter the order you put them in. So this is where you'd use a combination. If, let's say you were doing some other examples, maybe you were putting toppings on a pizza. Would it matter the order you put the toppings on? No, it would just matter how many toppings you are allowed to put on. If you're allowed 2 toppings in your group, 3 toppings, 4 toppings, etc. Or maybe you're putting ingredients in a salad, right? Whether you put the lettuce first and the dressing last, or whether you're feeling a bit wild and you want to put the dressing first and then the croutons and then the lettuce at the very end, it doesn't really matter. You're going to just mix it up all really good. And at the end of the day, you're just going to have this big mixed salad, and it doesn't matter the order you put them on. The only problem here is that in our English language, we have a bit of a confusion because you've probably heard something like this, a combination lock. So on your locker, you have a combination lock. But does it matter the order you put your numbers in? So if your combo is 25, 17, 11, can you put it in as 17 and then 25 and then 11? Well, no, the order you put the numbers in matters. So a combination lock is not actually an example of a combination. We should probably be calling it a permutation lock because the order you put the numbers in matters. So it's not a combo, it's a permo or something like that. All right, let's go ahead and hone in on this idea of a combination. How many 5-card hands can be dealt from a standard deck of 52 cards? Well, here, if you have 5 cards in your hand, it doesn't matter the order they're sitting in your hand. It just matters that you have 5 different cards. And so in this case, we're going to have a combination. This is going to be a combination because the order of the cards doesn't matter. Right? You're allowed to arrange them any way you want in your hand. You can hold them all in a big pile. You can put 2 in one hand, 3 in your other hand. You can just organize them however you want. The order doesn't matter. So it's a combination. Well, there's 52 cards in a deck of cards, and you're going to choose, or you're going to combine 5 of them. Now, this is probably a calculator question. So if you type in 52C5, you should get 2598960. Okay, let's go ahead and try an example ourselves. We're going to make a pizza shop, and we want to determine how many toppings to offer, so there's a lot of options. So let's just think of how many toppings we want. Well, we've got to maybe list them. Maybe we're going to have pepperoni, onion, mushroom, maybe tomatoes, maybe peppers. Maybe we're going to have some chicken, maybe bacon, maybe a few others that I can't think of right now. Oh, maybe some pineapple. So let's say we can come up with maybe 12 toppings. Okay, and we want to have a good number of choices, a good number of options at our pizza shop. So let's say we let people do a 3-topping pizza. Well, how would we determine the number of types of pizza you could make if you have 12 toppings to choose from? I didn't write out 12, but let's say I was able to get to 12, and you can choose 3 of them for your pizza. Well, you have 12C3. Go ahead and type that in on your calculator. 12C3 gives a total of 220 different pizzas. And so you can see that it's great. If you come up with 12 different toppings and you can choose 3 of them, so many different pizzas are available. It's so many that it feels like you're never going to run out of different pizzas to try. So let's go ahead and take some notes on this. The basic idea today is a combination. And when you're doing a combination, this is because the order doesn't matter. So whether you're thinking of cats in a group, whether you're thinking of toppings on a pizza, the order that you have the items doesn't matter. You're not putting things in a line. You're not putting things on a shelf. You're not making a password that has specific letters or numbers in order. You're simply making groups. And the way you always solve these is you use the NCR formula or your calculator, because this is the most efficient and this is our shortcut. It helps us solve these problems each time. So let's do an example. Let's say you're going to make a committee, and your committee needs to have 6 people, and you have 9 available. Who available to join? So there's 9 people who said, yeah, I'm available to join the committee. You only need 6 of them though. How many possible committees can you make? How many options are there? So I'd encourage you to pause the video and give it a try. Okay, so you should have 9C6 because there's 9 people to choose from and you only need 6 of them. This will be 9 factorial over 9 minus 6 factorial, 6 factorial. 9 times 8 times 7 times 6 factorial. And here we'll have 3 times 2 times 1. Then we can cross off the 3 with the 9, the 2 with the 8. So we have 3 times 4 times 7, and that will give us 84. Now you could also do this with a calculator, but this is how you do it without a calculator. So I'd encourage you now to try and add a question from worksheet 8. 8.5 especially is good to practice because there you get to choose whether it's a permutation or a combination, so a little practice determining which one is which. And then any things to remember, the main idea here is that the order doesn't matter, but of course if there's anything else you want to write down, you're always welcome to add more to that section. Alright, hopefully you enjoyed this video, and as always, thanks for watching.